Okay, now we're going to take a look at a ridge regression. And typically, you're going to use a ridge regression when you have a feature matrix that has a number of dimensions. It's really high dimensions, and let's say, in other words, you have a lot of features, but you don't necessarily have a lot of observations. So if you have a data set that has high dimensions, typically you want to use a ridge regression, or in this case, we have a very small feature matrix, but there's a lot of multicollinearity or correlation between the different factors. So one of the ways that you can deal with it is to run a PCA, as we did earlier, or you can use a ridge regression. One of the benefits of ridge regression is that you have something called penalization. And basically what you're doing is just adding beta to the model to make sure that you can penalize for having correlations between the different factors. So with that being said, it gives you a pretty clean output, and we're going to use it here. So let's go ahead, and we're instantiating the ridge regression model inside of sklearn. And let's just go back and take a look at the documentation. Uses least squares regression with L2 regularization. Okay. And you're going to hear a little bit more about this as we talk about neural networks. And it's also good for models that have a high degree of variance, if you will. So where overfitting is a problem. So that's where you're going to use a regularization technique like L1 or L2 regularization or ridge regression. Okay, so you have all the different factors here. And this is pretty interesting. So different solvers. So in other words, I'll let you take a look at or look at using these different solvers. And a note to self, if you want to optimize across the solvers, what you can do is use something called hyperparameter tuning. And you could actually place a number of these different solvers inside of a dictionary and then allow your computer to solve for the correct combination that gives you the best output. So we'll give you an example of that a little bit later as well. Okay, so I think you even saw stochastic gradient descent there as well. Really interesting, and we're going to talk about that later. And actually, we're going to code up a stochastic gradient descent as well when we hand code a neural network. Okay, so let's go ahead and get out of this and run it, and let's see. Okay, great. So what we have here is a ridge regression, and you can see that the correlations or the R-square is very strong here. So on the training set, we have 85.2, test set 85.9, about the same on each, which is pretty good. And again, we're just using this for visualization purposes. What the process that you would use when you were actually running this model is you would run basically what you would do is you would fit to the training set and then you'd run predict on the test set. So actually, essentially, yeah. So that's essentially what we're doing here too. When you use model.score, you're evaluating it, but we're not actually running the predict as you typically would in sklearn, because all we're doing here is we're just visualizing it. So for those who are wondering, well, where's the predict method at? And that it's basically contained inside of this scoring mechanism right here. So you're predicting and using that in order to generate scores for the model, if that makes sense. So again, great looking presentation ready model, and you can see that the distribution looks pretty normal to me, right? So you're looking at the residuals, evenly balanced, about the mean of 0. And you see the training set in red, and you also see the test set in gold, which is great. And you could just change the colors right here. So let's say you wanted to change the test from gold to, well, let's say green. No, green's not going to look very good. Let's just say blue. Okay, so there we go. Very patriotic, right? So it looks really nice here, and you can see the blues mapping out very closely to the reds. Okay, and yeah, looks great. So let's go further down. And one thing we might want to do is let's take a look at the map of the actual prediction error. All right, and so you can do that in a really simple way as well with yellow brick. So just 4 lines of code. You can take a look at the algorithm and how well it's fitting to the line. And you can see it does a very good job of finding that linear relationship. And we can see the benefits of penalization as well. So R square on the test set is 0.859. Again, the values that we're getting between test and training sets are almost identical. So that works out pretty well. Normalized data set, all that good stuff. So again, really simple to use, really good way to visualize how well everything fits to the line. So now what we're going to do next is we're going to take a look at classification analysis, and we're going to run it on a neighbor data set. And basically what we're going to do is look at recession data. So NEBR has some very interesting statistics on US recessions. You can get the probability that we are in a recession and a really awesome time dimension. And you can also take a look at making this a classification exercise when you have that data, because it's all in zeros and ones. So that creates some really interesting dynamics and very interesting problems. Okay, so let's go ahead, stop here, and we'll get started in just a moment after this break.